Have you ever wondered what holds the universe together? Today, we're diving into one of the most famous forces in history, gravity. This is the story of how humanity realized that the same rule that makes an apple fall from a tree also keeps the moon circling the Earth. It all started with a Danish astronomer named Tycho Brahe. He spent his entire life meticulously recording the positions of the planets. He didn't know why they moved, just how. Then came Johannes Kepler, a brilliant mathematician who took Brahe's mountain of data and found the hidden patterns. Kepler discovered three incredible things. First, planets don't move in perfect circles. They move in ellipses. Second, they speed up when they get closer to the sun and slow down as they move away. And third, he found a precise mathematical rule connecting a planet's orbital period to its distance from the sun. Kepler gave us the how, but the why was still a mystery. Enter Isaac Newton. He had a revolutionary idea. What if the same force pulling the apple to the ground was also pulling the moon, keeping it from flying off into space? He realized this force, gravity, must get weaker with distance. Not just a little weaker, but a lot. If you double the distance between two objects, the gravitational pull between them drops to 1/4. This is the famous inverse square law. He also figured out that the more massive an object is, the stronger its gravitational pull. This simple, elegant equation could describe everything from falling apples to orbiting planets, but there was a catch. To use Newton's law, you needed to know a special number, the gravitational constant, g. This was finally measured in a brilliant experiment by Henry Cavendish. He managed to measure the incredibly tiny gravitational force between two lead balls right here on Earth. Once we had the value of g, we could suddenly weigh everything. We could calculate the mass of the Earth, the Sun, and all the other planets. But the story doesn't end with Newton. He described how gravity worked, but he couldn't explain how the Sun could reach across millions of miles of empty space to pull on the Earth. It took another genius, Albert Einstein, to give us the next piece of the puzzle. Einstein suggested that gravity isn't a force at all. Instead, massive objects like the Sun literally warp and curve the fabric of space-time around them. Planets aren't being pulled, they're just following the straightest possible path through this curved space, like a marble rolling in a funnel. Gravity is actually the weakest force in nature. A tiny refrigerator magnet can overcome the gravitational pull of the entire Earth to hold up a piece of paper. But gravity has a superpower. It's relentless and can't be blocked. It's the invisible architect that sculpts galaxies, holds solar systems together, and keeps our feet firmly on the ground.